Good morning, everybody. Achieving, maintaining, and improving accuracy and reliability are the major challenges for clinical laboratories across the world. And this has become more relevant during the pandemic of COVID-19, which has affected the entire world. Today, the entire management of COVID-19 is dependent on laboratory diagnosis. The speaker for today, Dr. Neeraj Jain, is a founder president of Medical Education and Learning Point. He is also a lead assessor of ISO 15189 2012, the principal assessor of NABH, and is also been trained in Six Sigma Green Belt, ISO 17043 and ISO 13528. He has been awarded several awards and National IMA Award of Merit 2014, IMA National President Award 2014, DMA Annual Award in 2014 and 2017, HABX 2018 Award at CMC Vellore, and 10th Medgate 2020 Award. And he has also received the award for Best Institute for Health Education and Training. He is an accomplished educator of quality management, and he's a graduate and postgraduate from UCMS. And presently, he's running an NABL accredited lab in West Delhi. So I request Dr. Jain to start the lecture.
Thank you, Dr. V.K. Gupta, sir, for your kind words. So today our topic is, which is very relevant in the present time, interpretation of IQC and EQAS. If you see, what is the purpose of our medical laboratory? Purpose is to provide error-free report within reasonable time frame, so that these are meaningful for clinician and they can take proper action on that, and ultimately we are contributing through them in good patient care. For this, generally people talk about quality. Now we have to understand what is quality. The simplest definition is conformance to requirement. And when we talk about quality, we use different terminologies like quality assurance. What is quality assurance? We are telling somebody else quality requirements will be fulfilled. We are telling clinician you will get error-free report, and that error-free report within reasonable time frame. We are assuring them about the quality. For this, we require good quality control. When we talk about quality control, it is not only IQC or EQAS. Am I audible clearly, Dr. V.K. Gupta, sir? Yes. Am I audible, Dr. V.K. Gupta, sir?
Yeah, clearly audible.
Okay, right. So then, but we have to see, we require quality at all steps, pre-examination, examination, and post-examination. Because if quality is not maintained at pre-examination and post-examination, and we bring in automation, but all we get is automated mess, nothing else. To develop this quality control, what is required? A good, well-documented quality management system, which is including your quality manual, your quality system procedures, as per international document ISO 15189, standard operating procedure, how to carry out a particular test, what are the requirements. You have to develop different form and formats to maintain records. And also you are developing sample collection manual and lab safety manual. And if you see the process in our laboratory, process means sequence of activities. We are collecting sample, we are transporting sample, then we are receiving samples in the lab, and then after, suppose we have to prepare some anticodes and we have to send to different laboratories. Then in the laboratory, they are registering, they are testing, then interpreting results, reporting critical results are informed to clinician or patient immediately. All these process require a well-documented procedure at each step, so that there is harmonization in the working and we are not missing anything. Now for this, if we want to detect clinically significant errors, because if an error is reaching to clinician, he or she may take wrong decision. What is required? Our good results, which are cost effective, which a clinician can use. And suppose there is some error in our system, we are able to detect that error before it is reflected in the patient care. And for this, what we do, for this examination procedures, we follow IQC and EQAS. And we run IQC, we participate in EQAS. But suppose at a particular time it has failed, we are not getting the desired result. Now, what is the action we can take? For this, we will understand this concept in a systematic manner. First thing is, we have to change certain bad habits. Bad habits means, if a suppose control is not within acceptable limit, what we do? We repeat the control. Or we think calibration is not correct, we recalibrate the machine, then we are running control again. Or we say, this control I think has deteriorated, we will try new vial of control, we will reconstitute and then we will try next. But these are not correct. What we have to do, we have to identify what is the reason. First, we have to identify the problem, then root cause analysis, and then we have to take action. And whatever we are doing, a good documentation is essential. For this, we have to understand certain terms. Mean. What is mean? Sum of all data points divided by total number of data points. Mean tells us about accuracy. If suppose in a glucose, our target value, which is provided by manufacturer, is 100, and our mean is based on monthly data 90, that means instantly we are getting away from the. We have to take care of that. So that way, mean tells us about accuracy, and sometimes people are little confused what is good, whether it is manufacturer mean or lab calculated mean. Lab calculated mean is better because that you are calculating under your own precision condition. Your equipment is different, your calibration is different, reagent storage is different, reagent quality is different, control quality, control storage, calibration of your equipment, water quality, temperature, environmental temperature, so many variables, observer is different, so many variables are there. So we are taking into consideration all those things. Lab calculated mean is better, but we have to understand the mean should be close to manufacturer mean. It should be within one standard deviation of manufacturer mean. Now we are calculating our own mean, but we also have to understand there is no significant variation in our day-to-day testing. For this, what is the statistical tool we have? Standard deviation. It is also provided to us by the manufacturer. We have to ensure our calculated standard deviation is not wider than the manufacturer standard deviation. And our calculated mean is within one standard deviation of manufacturer mean. So for this mean, for this standard deviation, we have two things, two statistical tools. One is standard deviation. Now look at this formula. Don't go by the complication of this formula. It is very complicated. Concentrate on this aspect, x minus x bar. X bar is the mean value. Higher the difference between individual data point and mean value, higher will be the square. Higher square means higher will be the sum of squares, and ultimately higher will be the square root. That means high standard deviation indicates more variation in the data, and less standard deviation indicates less variation in the data. So therefore, standard deviation is a tool to tell us whether the variation is more or variation is less. But if suppose we want to compare analyte of different ranges, suppose we want to compare uric acid with cholesterol. In case of uric acid, standard deviation is 1, and in case of cholesterol, standard deviation is 10. And mean value of uric acid is 5, and mean value of cholesterol is 200. Where the variation is more? If we go by standard deviation, we will say variation is more in case of cholesterol because standard deviation is high. But if we take the ratio 10 out of 200 and 1 out of 5, obviously the ratio is more in uric acid. if we want to compare data of different ranges, then the best tool is coefficient of variation. Therefore, accreditation bodies also ask for CV%, because with this they can compare variation in different analytes, where the variation is more, where the variation is less, and always use this CV only up to 1 decimal point and at least up to 1 decimal point. Because if you are calculating in your computer, it may give you 6.8236, 7.2498. So that much is not required. And even 6%, 7%, 8%, that is also not acceptable. 6.2, 6.4, even if it is 6%, right, 6.0. This is how we express. And these things, mean, standard deviation, and coefficient of variation, these we are calculating with our quantitative IQC data, because we are getting multiple data points only in IQC. Class sample we are running only once, so we cannot calculate any mean or standard deviation in our laboratory. With IQC, so we are getting information about precision, how close our results are to each other. With EQAS, we are getting information about accuracy, how away we are from target value. So both are important, precision as well as accuracy. So now first we will discuss this precision aspect, how we can control variation in our data. For this, we are participating in this internal quality control. And how many levels shall we run, how frequently these shall be run, this depends on workload and distribution of work. And how these are evaluated? Based on levy-jennings charts and Westgard rules. And also we can use the Six Sigma. But the Six Sigma is a very lengthy topic. This requires altogether a separate session. But for your information, just for the sake of completion, how we can evaluate, I have mentioned this Six Sigma also. But generally people follow levy-jennings charts and Westgard rules. These charts were first described by Dr. Schwartz. In medical laboratory, their use was first described by Dr. Levy-Jennings. Therefore, in medical laboratory, these are called Levy-Jennings charts. We will discuss those charts, but first we will see what is required for this IQC. One thing is documented procedure in your laboratory. You are saying in hematology, I am participating in this EQAS A, in this IQC. We are running control daily, 2-level control twice a day, or whatever is your system. In biochemistry, this is our system. This need to be reconstituted. This vial will be reconstituted with deionized water, or if suppose they have provided you some diluent. And this controls will be run by the person who is routinely performing the test. So you are first documenting the procedure so that everybody is following that. Then you are implementing your documented procedure. Regularly, you are reviewing your data. Whenever you are detecting any outlier, that means some result is not acceptable. Then you are taking corrective action on that, and you are monitoring that corrective action for its effectiveness. And again, I will emphasize upon documentation, documentation, documentation. Everything shall be documented so that it is clear what is happening in our laboratory. Now we have to understand when we are running controls daily, how we will evaluate these. We will prepare levy-jennings charts. In this, we draw two lines perpendicular to each other. Horizontal line is intersecting this vertical line at its midpoint. On the vertical line, we write mean value of the control, and above it, 1 SD, 2 SD, 3 SD. Below it, minus 1 SD, minus 2 SD, minus 3 SD. And on a horizontal line, we write number of observations. If suppose we are running 1-level control twice daily, one morning, one evening, 2 morning, 2 evening, and what is required for different analytes, we prepare different levy-jennings chart. For different level of control, we prepare different levy-jennings chart. But if suppose same level of control for a particular analyte, we are running more frequently, suppose twice in a day or twice in a day, same levy-jennings chart will work. And we are plotting our daily observations on this chart, and when these points are joined, this is called levy-jennings chart. All these things are provided to us these days by our machines, but what is important? We have to understand the concept, how machine is plotting all these things. Now we have LJ chart with us, but why we are running all these things? We want to know whether a result on a particular day is within acceptable limits or not. For this, we follow Westgard rules. And minimum essential is you follow two rules. If suppose one value is beyond 3 standard deviation, that means it is significantly away from rest of the data. Stop testing. Do the root cause analysis. What has happened? Why it is away? Do the root cause analysis, take appropriate action, run control again. When that control result is within acceptable limit, only then run patient sample. If one value is beyond 2 standard deviation, once you can accept this, but carefully watch next run. If that is again beyond 2 standard deviation, that means something has happened, which has started our all results. Stop testing. Do the root cause analysis, take appropriate action, after that run control again, and then run patient sample. If 2 consecutive readings are showing significant variation, although within acceptable limit, and if this variation is 4 standard deviation, this is not acceptable. What has happened? Has the reagent deteriorated? Or there is some leakage on the tube or some other problem? What has happened? Do the root cause analysis, take appropriate action. These things are guiding us. Before a problem is detected in the patient sample and patient is complaining or clinician is complaining, we can detect that error in this control material. And another thing is, there is no perfect way to troubleshoot. You will not find any book where you can read all these things and you can make it. All these things we learn by our experience and by the experience of our colleague. But we have to stop this practice whenever there is out of control situation. We are recalibrating. In this unnecessary, we are inviting other problems. Suppose there is Dr. V.K. Gupta sir, can you keep yourself muted? Failed QC. We have to understand the problem. Yes, there is some problem. Then we have to review levy-jennings chart, which we are preparing on the basis of this QC data. Then we have to see what is the type of error, whether it is systematic error, which is affecting our all results, or random error. Some error has happened suddenly. Whatever is the situation, proper root cause analysis and corrective action is important. And again, whatever is the situation, document, document, and document. First, we have to understand the problem. If there is problem, how we get information about this? By a out of control event, by recognizing out of control event through our QC multiple rules, which we are analyzing on our levy-jennings charts, which we just discussed. And when we review this levy-jennings chart, we see what is the problem and sometimes what happens. These results are not in out of control situation. It is beyond 3 standard deviation, or 2 values are beyond 2 standard deviation, or 2 consecutive values are showing variation of 4 standard deviation. But you can see this upper graph. Results are moving in one direction. Although variation is less, but it is progressing in one direction. This is called trend. We have to notice this trend before it becomes outlier. And we have to see what has happened. Is there is some problem with the reagent storage or control material storage? We have to identify all these things. Sometimes what happens, if suppose you are reconstituting a new vial of control. Previously in glucose, you were getting results close to 99.6, 99.8, 99.4 like that, and suddenly now you are getting result 105 after reconstitution, and then 105.3, 105.4, close to 105. This is called shift. Results have shifted in one direction, and those then are maintained in that shifted position. So whatever is the situation, identification and proper action is very important. So now, for this root cause analysis, what is required? We should have effective troubleshooting procedure in place. How we will do the troubleshooting. And whatever you are doing, document. First, we have to identify what is unique to the situation. If suppose you are facing some problem, whether you have changed the reagent, or you have changed the control material, or you have changed the calibrator, or some recent maintenance has happened, or there is some replacement of the part, or operator has been changed. Is there something new? Then what is common to the situation? If suppose more than one chemistry affected, whether these you are performing on the same filter or on different filter, or all are kinetic, or all are endpoint, so we have to see, or on the single level control affected or multiple level control affected. And also see environmental condition, water system, pH and resistivity is okay, ambient temperature is okay, and who accepted the reagent at the time of accepting those reagent, whether everything was okay or not. We have to analyze all these things. And sometimes what happens, a very common situation, we have changed the lot of control, but people are using the old insert. They are thinking this comparison chart is same. We have to see we are using this package insert of new lot only. All these things, whether the calibration set point is correct or not, all these things, any error message in the machine, all these things we check, and then we take appropriate action. When we troubleshoot, we have to see is something has happened with control, or with reagent, or with calibrator, or with instrument hardware, or in environmental condition, or something related to operator. Person who is performing all this activity may not be trained to carry out all these activities. For control, correct material. It should not be expired. It is stored properly. If you are preparing aliquots, you are preparing aliquots of aliquots in the append of tube of appropriate size. These are neither too large and not too small. Then these are reconstituted properly, and when you are bringing those to room temperature, you are running promptly so that some material is not evaporated. If it is evaporated, you may get higher result because of the more concentration, or some water droplet may fall in the control material, you may get lower value. If suppose control material is okay, then look at the reagent. Whether you have placed correct reagent at the correct position, or if it is new reagent, you have performed lot acceptance testing properly. These reagents are stored properly. Yesterday we discussed what are the advantages of onboard cooling. If it is onboard cooling, it is okay. Otherwise, these shall be stored in the refrigerator properly. And there are no bubbles in the reagent. These are not expired. If you are using a new lot, you have performed lot acceptance testing. Calibrator. If this calibrator is not expired, if suppose some reconstitution is required, it is reconstituted properly. And you are loading these calibrators at the proper position, and you are noting down all data related to calibrator, and after this calibration, you are checking your machine with the controls, you are getting control results within acceptable limits. Then instrument hardware, you're taking care of proper maintenance, daily maintenance, weekly maintenance, monthly maintenance. You have official AMC or CMC with you, and whatever maintenance solutions, cleaning solutions you're using, those are not expired. And also visual inspection about problem. There is no leak or some deposits in the probe, or these tubes are torn. All these things are not there, and everything is working in a proper manner. Cuvettes which you are using, these are, if suppose you are cleaning, those are cleaned properly, scratches are not there. They are taking care of all these things related to hardware. And also the person who is operating your machine, who is taking care of all these things, shall be trained to take good care of all these aspects. And also the water which you are using has correct pH, correct resistivity. If you have installed plant, so you are checking all these things regularly. If you are buying this deionized water from your vendor, so you are taking care. They are providing you good quality of water, and also see laboratory temperature and humidity. And there shall not be excess carbon dioxide or alcohol fumes. Now you have checked all these things. Still, what happens sometimes? You're not able to find anything. Then it may be considered as random error, some voltage fluctuation. So then you can classify that as random error, and you are running control again. And if that control result is within acceptable limit without any corrective action, then this may be classified as random error. But if you are getting this random error very frequently, that means there is some problem in your root cause analysis. So after solving problem, you are running control again. But important thing is, again I will emphasize upon document, document, document. The important thing is you perform QC according to your SOP, troubleshoot in a structured manner. This we are talking about IQC. Do not report patient result unless you have corrected this QC failure, and do not recalibrate without any action. But in hematology, situation is little different because stability of controls is less. It is not possible to analyze by LJ chart because you will calculate your monthly mean, and next month you will get new lot. You cannot use previous month mean and standard deviation for that lot. Then what we can do? We can compare CV percent. For every lot, you calculate CV percent and you compare this CV percent. And if you are using 5-part differential, sometimes people, what they do for this differential, neutrophil 76%, lymphocyte 36%, or 28%, whatever are the percentages, daily they are getting percentage in their machine. Then they take the percentage of those percentages to check the variation in differential. You calculate variation in this differential for controls based on your absolute values of neutrophil, of lymphocyte, of eosinophil. Then after precision, we have to look for accuracy also. For this, what we do? We follow this Z-score. This is also known as standard deviation index. This is for quantitative results. For qualitative, it is comparison with peer group or evaluation criteria. In this, we go by the majority. For this qualitative test, suppose you are participating in histopathology EQAS or microbiology EQAS for culture, or for serology, we go by the majority. If more than 75% participants are showing result in one direction, then we think they are correct. But if suppose 60% are saying in a particular case, sputum for AFB is positive, 60% are saying positive, 40% are saying negative, then there is some problem in that material. So we have to reject that run. Now, what is required? As we discussed, for this EQAS also, we shall have documented procedure. Participation is mandatory. If national EQAS is available, it shall be treated as a routine sample, analyzed by a person who is routinely performing all the tests, not to be discussed with the peer group, not to be sent to referral lab, and if there is any outlier, root cause analysis and corrective action, and again documentation. How the Z-score is calculated, although it is provided to us by our PT providers, but how it is calculated? Lab result minus assigned value. In generally, most of the EQAS providers, PT providers, they are following group mean as the assigned value, divided by standard deviation of the group for that particular analyte. And if the Z-score is within 2, minus 2 to plus 2, it is within acceptable limit. If it is 2 to 3 or minus 2 to minus 3, it is warning signal, and less than minus 3, more than 3, it is action signal. 2 warning signal or 1 action signal indicates intervention. We have to see what has happened. With 1 warning signal, we are watching carefully the next run. And some useful tips which you can follow. IQC and EQAS, these are essential in all labs. Sometimes people say we have very little workload. It is not possible for us, or we are very good quality conscious. We are sitting 24 hours in our lab. So therefore we are taking good care of quality. So these things are not for us, but no, these are excuses. And remember, cost of cost cutting is high, because ultimately we lose reputation, morally also feel bad, and commercially also we have to rerun the samples, and we sometimes lose patients. And sometimes people say EQAS is not required because I'm participating in IQC. We have already discussed with IQC, we are checking precision, and with EQAS we are checking accuracy. So both are essential. And this IQC sample shall be stored at appropriate temperature, and always prepare a liquids of appropriate size. Your staff shall be well trained to carry out all these activity, and again good documentation and documentation. And ultimately the end result will be you and patients both will feel happy. You are releasing correct results and they are receiving correct results. With this a little extra care, and we are helping clinician, and we may contribute in saving one more life.